In this final video of the prediction series, we're going to summarize the results that we found in R for our confusion matrix. We talked about how we would never want to show a supervisor or a client some R results because it would be confusing. We've labeled our variables in strange ways. We need to present things in a clear way that we consciously design based on the conclusions that we want our client or manager to be able to draw from what we've created. So instead of thinking about our output, think about this. See how I've organized into a nice, attractive, meaningful presentation where I can see the percentage of times that a 0 was predicted and a 0 was actually found to be true. So we've got 2% of the time that we predict no donation and we actually don't receive a donation. We've got 95-ish% of the time that we predict we're going to receive a donation, and then we do, which is great. So we're correct about our predictions 2% plus 95% of the time. So that's about 97% of the time that we correctly predict whether we're going to receive a donation or not. Here's the results for the test set, and we can see that they're pretty consistent. We've got 2% of the time that we correctly predict no donation, and about 95% of the time that we correctly predict receiving a donation. The performance is similar in the training and test sets. So we have 2% in this box, 2.5% in this box, just under 1% in this box, and about 95% in this box. This shows good stability. We're going to judge on the same characteristics that we did for linear regression, stability and accuracy. But the similarity between training and test sets indicates that I can rely on this model when it's predicting new situations. So that's a good sign. Stability is important for my trusting future use of this model. Now, 3% of the time, I predict in either the training or the test set, I can look, 3% of the time or 2.5% of the time, I predict that we are going to get a donation and then we actually do not. So that's kind of a concern. If you think about a nonprofit organization that runs on donations, if 3% of the time I think I'm going to receive a donation and I've counted it potentially in the operating budget for the year, and then I don't get a donation, that could be a big blow to that operating budget. Maybe I'm not going to be able to implement a program that I thought I was going to be able to implement. When we look at the other kind of error, where I predict I'm not going to get a donation, but then I do, the actual value is 1, the predicted value is 0, that's happening just under 1% of the time, where I'm surprised in a positive way. I think I'm not going to get any money from this person, but then suddenly I do. This is actually a good outcome. It's not good necessarily in a statistical model to predict incorrectly, but in terms of what it means for the business, it's a nice positive surprise to my operating budget. So I do want to be thinking about how often I make mistakes, which is about 3.5% of the time in total. But I want to think about what kind of mistakes I'm making and which one is more common. Because for understanding business intelligence, that's an important thing to think about. So more commonly, I'm predicting that we get a donation and we don't. And there's where the trouble is going to be. When I've already designed my operating budget potentially based on receiving donations from certain people, and then 3% of the time I don't get it. So when I ask the question, is this model good enough? It needs to address both stability and accuracy. So stability is the comparison of training to test, where I can trust my model to make predictions on data that it's never seen before if the results in the training set and test set are similar. And accuracy is about how often do I make errors and what kind of errors do I make. So my results for this model are, well, about 97% of the time I'm making correct predictions because I predicted a 0 and got a 0, or predicted a 1 and got a 1. So that's great news. I'm commonly correct. But about 2.5%, 3% of the time, I think I'm going to get a donation and I don't, which is a real problem. Less commonly, less than 1% of the time, I'm surprised in a positive way by an unexpected donation. So this is about communicating my results to my manager in a powerful way. My manager can look at this chart and say, wow, I understand exactly how often I am correct and not correct when using this model. I would say being correct about 97% of the time, that's probably good enough to use this model as a starting point. We can always improve.